embarking on a pretty deep analysis. We're not just looking at the future, but really analyzing the present. And it's this rapid transformation of one of the most fundamental systems in society, education.
Right.
The source material we've gathered is, well, it's pretty much unanimous. The shift brought about by artificial intelligence in how we learn, how we teach.
And maybe most importantly, how we prepare for what's coming.
Exactly. Continuous adaptation. It's unlike anything we've seen before.
It really is a historical moment. I mean, we've seen big educational shifts before, right? You have the printing press, which completely changed how content was distributed.
Or the internet giving us just boundless access to information.
But the sources all confirm that AI is different. It's not just a new way to deliver the same old stuff.
No.
It's an active, intelligent, and a highly personalized system that's being built right into the foundation of learning itself.
And it's already here. That's the key thing. It's not theoretical anymore. It's in our classrooms, our universities, our study platforms.
And it's demanding a whole new level of literacy from everyone involved.
Okay, so let's unpack this. AI is no longer this concept floating out in the future. It's the operational reality today.
Right now.
So our mission for this deep dive is to give you, the learner, a complete map to this new territory. We are going to go beyond the headlines to understand the how and the why.
Precisely. We'll be starting with that foundational concept of personalization, how AI is finally, maybe, killing that one-size-fits-all model.
Which has been the standard for centuries.
For centuries. Then we'll tackle the technical core, demystifying the mechanics of AI, things like data, algorithms, and computing power, while also clarifying some of the jargon.
Yeah, that's a big one. AI versus machine learning versus AI engineering.
They're not the same thing, and we need to know the difference.
We'll also spend a good amount of time on the critical element of responsible use. How students and teachers can partner with this tool to enhance, not replace, human intellect.
And we have to get into the technical backbone, which means explaining why a language like Python is suddenly a mandatory skill.
Right.
And then we'll wrap up with a look forward. What skills do you actually need to succeed when adaptability is, frankly, the single highest currency in the professional world?
So if you want to know what it means to be truly well-informed about the AI transformation in education, this is the deep dive for you. When we look at the traditional model of education, the fixed lecture hall, the standardized curriculum,
the same pace for everyone,
and the move on or fail pace, we have to admit that system wasn't really designed for pedagogical effectiveness.
No, not at all.
It was designed for economic scalability.
One teacher, one book, one curriculum for hundreds of students across a massive system. It's an industrial model.
And that economic efficiency, well, it came with some profound hidden costs, which the sources really dig into.
Oh, absolutely. That fixed pace was the fundamental flaw because it failed to recognize a basic truth. Learners are profoundly heterogeneous. They're all different.
They absorb information at different rates. They process it differently.
Some are visual, others learn by doing. And if traditional curriculum says, okay, 2 weeks for geometry, then we move on, what happens to the students who needed 3 weeks?
They're left behind. And it's not just for that one topic, it's a cumulative gap.
It's a cumulative knowledge gap that just gets wider and wider, and it often results in students struggling for years or even dropping out.
So that fixed model basically created these persistent equity gaps. It rewarded the students whose learning style happened to line up with the standard method.
And it penalized everyone else.
And what's so fascinating here is how AI finally gives us an economically viable solution to this centuries-old problem.
The whole equation changes because the AI system is designed to respond dynamically, moment to moment.
So we're moving past this idea of a generalized education
to what the sources are calling genuine personalization or even hyper-personalization.
Okay, so how does it do that? Let's get into the specific capabilities. How do these AI systems actually move beyond just, tracking a final score on a test to genuinely adapting the material?
It's a really multi-layered process. First, the AI system adapts lessons based on a student's performance, but it does it in real time.
Okay, so what does that look like in practice?
So imagine a student is in an interactive algebra lesson, and they're consistently struggling with one specific step, like isolating the variable.
Right.
The system doesn't just flash an error message, it initiates a subroutine. It might generate 3 visually different examples of that exact step. Maybe presents a short explainer video on inverse operations.
And only then does it bring the student back to the original problem.
Exactly. The whole system is focused on achieving demonstrable mastery of that one single concept before it lets the student move on.
That dynamic, responsive feedback, just a lot. It eliminates that painful lag time. I remember waiting days, sometimes weeks, for a teacher to grade something and give it back.
And by then, the class is 3 topics ahead.
Exactly.
And secondly, there's the automated proactive recommendation engine. The system is designed to spot patterns across the entire curriculum.
So it sees the bigger picture.
Right. If a student is acing all their biology quizzes but is showing a consistent weakness in statistical analysis.
Which happens a lot.
It happens all the time. The AI automatically suggests supplementary learning materials, maybe some targeted drills, or a little micro-module on interpreting R-squared values. A human teacher would never have to manually diagnose that specific, nuanced gap.
That level of intervention is just... It's not feasible for one teacher managing a class of 30 students.
Not possible.
And the elimination of the anxiety, the waiting game.
Right.
That's huge. The sources really emphasize the psychological benefit of that instant feedback.
Well, it can identify those knowledge gaps early and provide specific, actionable feedback the moment the mistake is made.
So if you submit a complex coding problem, it doesn't just say incorrect.
No, it'll say something like, your variable declaration on line 17 doesn't match your function call on line 42, and that's resulting in a name error. That level of specificity just accelerates the learning curve dramatically.
And this capability is driven entirely by the depth of data tracking available in these online learning platforms, isn't it?
Completely. The shift to digital learning isn't just about, getting the material online. It's about generating detailed, continuous behavioral data that was impossible to collect in a physical lecture hall.
So can we break down the type of data the platforms are actually tracking? Because it goes way beyond just which answers were right or wrong.
Oh, absolutely. The systems are measuring minute behavior, and that gets fed directly into the algorithms.
Like what?
Well, they're tracking metrics like dwell time. Which specific topics or questions a student spends the longest on before answering or giving up.
Which indicates cognitive friction, a sticking point.
Exactly. They pinpoint the exact moments or types of questions where mistakes frequently happen. This lets the AI cluster weak points across the whole student body. And crucially, by analyzing successful learning paths, they're determining the most effective learning modality. Is it visual, auditory, textual for that one individual?
So the system is constantly building this, like a precise, meticulous cognitive profile of the student's interaction.
Right.
It's measuring engagement and efficacy, not just performance.
But that brings up a critical question.
Right.
One the sources definitely address.
If the AI is constantly profiling the student, how do we make sure the student maintains a foundational structure? How do they not just chase these individualized tangents and lose the coherence of the course subject?
That's a necessary check on personalization. It's a really important point. The sources explain that the AI model is built on 2 layers. You have the core curriculum layer.
Okay, the non-negotiables.
Right, that ensures all the mandated concepts are covered. And then you have the adaptive layer, which is what varies the pace and the modality of the delivery.
So the path can be flexible, but the destination is fixed.
The destination mastery of the core concepts is fixed. The AI's goal is to find the most efficient route to that fixed outcome for that specific student.
The massive takeaway here is that the entire educational model is shifting profoundly. We're moving from a generalized education designed for a theoretical average student.
An average student who doesn't really exist.
Right, and it often missed the mark. Now we're moving to learning that is meticulously designed for each individual's unique cognitive profile. This is the promise of AI in the classroom.
And this personalization extends far beyond the typical classroom. It's about removing real-world educational barriers. This is the democratizing effect.
Let's talk about that. Think about the 3 traditional limits of education: location, time, and language.
AI helps demolish all 3.
So first, it enables learning anytime, anywhere.
Precisely. And this isn't just about, watching a recorded lecture. It's about flexible, asynchronous learning that's tailored to any working schedule, any geographical location, any time zone.
For people needing to upskill while holding down a job, that's transformative.
It's a game changer.
Yeah.
Furthermore, you have these high-quality, real-time language translation tools. This means that specialized content that's taught in, say, German, can be immediately accessed and understood by a learner in Brazil.
Which enables truly global education experiences. It breaks down these national monopolies on knowledge.
And then there's accessibility, which At its core is an equity issue.
Absolutely.
These AI-powered accessibility tools provide just, crucial support for students with a wide range of learning and physical disabilities, people who are severely underserved by rigid physical classroom setups.
Things like complex screen readers or formats that respond to voice or eye movements.
Real-time captioning. All these things are driven by sophisticated AI models that remove physical and cognitive hurdles.
So the summary here is that education is no longer restricted by geography, by time, or even by the availability of specialized human resources.
It's become a customized, global 24/7 resource.
Okay, so we've established the profound impact of AI on the learning experience. But for an informed audience, we have to move past the idea that AI is some sort of, black box or magic.
Right.
We need to demystify it. The sources really emphasize that to use the tool effectively, you have to understand its architecture.
That's right. If you're going to be an active architect of your own learning path, you need to understand the material the architect is using.
And the sources break down the architecture of any functional AI system into 3 essential interdependent pillars.
Right.
Let's start with pillar 1, data.
Data is the foundational input. It's the fuel. An AI system cannot learn without it.
Simple as that.
Simple as that. Whether we're talking about petabytes of text, billions of medical images, or the behavioral data we just discussed. This is what trains the system.
But the principle is more complex than just garbage in, garbage out, isn't it?
Oh, much more complex. The critical effort isn't just collecting billions of inputs. It's the human labor of labeling, weighting, and curating that data to make sure it's minimally biased, that it's relevant, and that it's useful.
That process, that's data governance and feature engineering.
And that is currently the most significant bottleneck for developing truly high-quality AI.
So the intelligence isn't inherent in the machine. It's a reflection of the quality of the input we feed it.
Exactly.
So if the data used to train an educational AI only has examples from, say, urban high-resource schools,
Then that AI may perform poorly when you deploy it in a rural or a low-resource environment, simply because its training data lacks that context.
okay, so data alone isn't sufficient. You need rules to process it. That brings us to the second pillar, algorithms,
This is the engine.
the engine.
Algorithms are the complex mathematical rules the machine uses to identify, process, and predict patterns within that vast ocean of data, and their function is dynamic.
So they decide what the machine pays attention to.
What it pays attention to, how it calculates probability, and how it adjusts its own internal rules based on the errors it makes during its training phase. It learns.
Can we touch on the types of algorithms that are most relevant to education, just to give listeners that technical flavor?
Certainly. In educational AI, you primarily see 2 types of machine learning algorithms. You have supervised learning and reinforcement learning.
Okay.
Supervised learning is used for things like predictive modeling, predicting a student's future grade based on their current behavior, for example. The system is trained on historical data, where you have the input paired with the correct output.
And reinforcement learning.
That's used more for adaptive tutoring. That's where the system learns the optimal teaching path by trial and error. It gets a little reward signal every time the student successfully grasps a concept.
So these algorithms are the continuous self-tuning mechanisms that create that feeling of responsiveness.
That's right.
And finally, the third pillar, the one that often goes unsaid but makes all of this real-time response possible, computing power.
The sheer horsepower. You need these extraordinarily strong computing resources. We're talking hardware, often highly specialized GPUs or clusters of processors, to process these massive data sets efficiently.
And at the speed required for a real-time interaction.
And it's not just about faster chips. It's about massive parallelism, the ability to run millions of calculations at the same time. Without that infrastructure, the adaptive intervention we talked about earlier would take hours, not milliseconds.
Which would render the whole personalization idea useless.
Completely useless.
So these 3 components together, the curated data, the complex learning algorithms, and massive parallelism, allow AI in education to move beyond just static delivery and to actively understand and respond to the nuances of learning behavior.
It's a fundamentally different thing from any previous educational technology.
Speaking of differences, the jargon is a persistent hurdle to AI literacy. You hear AI, machine learning, AI engineering. People use them interchangeably.
All the time.
But we really need to address the distinctions to get the level of knowledge we need.
This is a critical area for clarification. We have to understand the hierarchy.
So let's define artificial intelligence, AI, one last time.
AI is the umbrella. It's the broadest concept. It is the simulation of human intelligence by machines, the overarching vision of creating systems that can perceive, reason, and act.
It's the ultimate goal.
The ultimate goal.
Okay, moving inward from that umbrella, we have machine learning, or ML.
ML is the dominant methodology we use today to achieve that goal. It refers to systems that learn patterns from data without being explicitly programmed for every single outcome.
So instead of writing 10,000 rules,
You give the system 10 million examples, and it infers the rules on its own. The sources label this distinction really clearly. AI is the vision. Machine learning is the primary learning method.
okay. Then finally, the essential link between the theory and the user. AI engineering, this is the functional integration phase.
This is the deployment phase. These are the people who make it work reliably. AI engineering is the practical discipline responsible for taking a functioning machine learning model,
Which might work perfectly in a lab.
right, in a controlled testing environment,
Yeah.
and integrating it into a reliable, scalable, and secure real-world application, like a massive university learning platform. Their responsibilities cover everything from system architecture to integrating software pipelines, often called MLOps, and ensuring consistent performance for millions of users at the same time.
So if an ML scientist figures out how to predict which students are at risk of dropping out,
Then the AI engineer designs the robust system that ensures that predictive model runs flawlessly on the cloud, delivering that information instantly and securely to the right academic advisor.
exactly, it's building and maintaining the real usable systems.
And the crucial takeaway for our audience here is that future education has to prioritize application and system building, these AI engineering concepts, because that is where the economic and functional value truly lies.
We need thinkers who can move a concept from a lab bench to a functioning, scalable enterprise. That sets the stage perfectly for how we use this immense capability. We have to start with the non-negotiable principle that all the source material establishes. AI should support and enhance human education. It should absolutely not replace the teacher.
Right.
It's fundamentally a partnership.
The irreplaceable elements remain human. A teacher's empathy, their ability to mentor, to inspire curiosity, to manage complex social and emotional dynamics in a classroom.
AI can't do any of that.
Not at all.
Mm-hmm.
AI's role is purely to handle the data processing, the repetitive tasks, and the personalization at scale. It frees up the human teacher to focus on higher-order thinking, critical analysis, and interpersonal engagement.
So for students, the challenge is clear. How do we use this tool for deeper engagement without succumbing to intellectual dependence?
Right. Using it to generate the answer instead of understanding the process.
So we need to focus on responsible, high-leverage uses.
We have to fundamentally shift the student mindset. They need to view AI strictly as an interactive tutor, a tutor for explanation and conceptual understanding.
Okay, so if a student is stuck on a complex thermodynamic concept,
The AI shouldn't just give them the solution to the homework problem. It should be used to explain the concept in 5 different ways. Use analogies from steam engines or refrigerators or rocket propulsion, whatever resonates best. And then it should check their understanding step by step.
the focus is on the learning process, not the final product.
Always.
And we have to leverage the power of that focused practice and instant feedback we talked about.
That's the second key use. Students can access endless practice problems with immediate, specific feedback. This is a complete game changer for skills acquisition.
For a technical writing assignment, for instance.
The AI can immediately tell the student, your use of passive voice in paragraph 3 weakens the argument. Try rephrasing the sentence to focus on the active agent. It targets the specific logic or the structural flaw. It doesn't just assign a generic low grade.
Furthermore, AI serves as an excellent initial comprehension tool, right? Especially when you're dealing with information overload.
Precisely. Students can use AI to summarize overly complex or voluminous topics to just get a handle on them.
If you're faced with a massive 100-page academic paper,
The AI can break it down into its 3 core arguments, identify the key data points, and list the unresolved questions. This allows the student to approach the detailed reading with a foundational conceptual framework
which improves retention and focus.
dramatically.
And for students learning technical skills like programming, AI coding assistants have become foundational tools. They're dramatically accelerating the learning curve.
They are powerful beyond measure. Think about the old frustration of hitting a brick wall in Python and spending 2 hours staring at a missing comma or a logical loop failure.
We've all been there.
We've all been there. The AI coding assistant turns that moment of debilitating frustration into an immediate teaching moment. It gives you the debugging tip, it explains the logical flaw in the code's flow, and it offers a better, more efficient way to achieve the goal.
It just accelerates that whole cycle of design, failure, correction, and success.
Right.
Okay, now let's flip the lens. How does AI benefit the teacher? How does it help combat systemic teacher burnout through automation and efficiency?
This is where AI provides immense structural relief. It frees up vast amounts of teacher time that was traditionally devoted to repetitive, often tedious tasks.
Okay, give us the specifics on the grading front.
First and foremost, the automation of grading. Now, essays still require human nuance, but AI can grade 100 multiple-choice tests, short answer assignments, or coding submissions in minutes.
But crucially, it doesn't just provide a score.
No, it generates detailed aggregated data back to the teacher. It might show, for instance, that 70% of the class struggled with question 4.
Which indicates a failure in the teaching method, not a failure of the students.
Exactly. And that data allows the teacher to adapt their instruction for the very next day.
Right.
And beyond grading, the AI can generate customized lesson plans and supplementary materials rapidly. A teacher can input the core curriculum standard and ask the AI to generate a modified lesson plan for 5 students who are reading 2 grades ahead.
Or, conversely, enrichment materials for students who need more hands-on examples.
It reduces that prep time that used to stretch late into the evening from hours down to minutes.
And on the management and administrative side, tracking dozens or hundreds of students.
AI excels at that. It efficiently tracks large-scale student progress across multiple metrics. It really acts as an early warning system.
So if a student's engagement suddenly drops or their mastery plateaus,
The AI proactively flags that student's profile. And this allows the human teacher to focus their limited one-on-one time exactly where it is most critically needed. It pivots the teacher's role from a reactive administrator to a proactive mentor.
this brings us to what might be the most crucial skill identified in our sources: the imperative of teaching responsible use and cultivating critical thinking.
Yes.
We have to teach students how to drive this powerful machine, not just sit passively in the back seat.
This is the new definition of literacy. If we are giving students access to these unprecedented information generation capabilities, we have to simultaneously upgrade their skills to manage, vet, and command that tool.
So let's start with what the sources call prompt engineering.
Prompt engineering is the primary new cognitive skill. It's the ability to ask high-quality, effective questions that yield analytical insight, not just regurgitated facts.
So it's moving beyond asking, tell me about the French Revolution.
To asking something like, act as a historian specializing in economic drivers and explain 3 unintended consequences of the continental system on 19th century European trade, and format your answer as a 3-point academic brief.
The quality of the output is dictated entirely by the quality, structure, and specificity of the input.
100%. The student needs to become a skilled director or editor of the machine's output.
That's a perfect description.
And secondly, students have to develop robust, disciplined methods for verifying AI outputs.
Because AI models, for all their sophistication, are known to hallucinate.
They confuse facts, they propagate biases from their training data. Students have to be taught fact-checking methods, how to triangulate information across multiple sources, how to spot logical gaps, and how to treat AI output as a highly efficient first draft, not infallible gospel.
And underpinning all of this is the necessity of cultivating fundamental critical thinking skills. This is the intellectual insurance policy.
Absolutely. The system has to ensure that AI output is always analyzed, questioned, and synthesized by the student's own mind, rather than just being copy and pasted.
The core message is powerful.
It is. AI is the most potent intellectual tool ever introduced into the learning environment, but it is not, and it cannot be, a replacement for human thought and intellectual effort.
The focus must always remain on the human mind doing the hard work of thinking, analyzing, and judging. Okay, moving on to the foundational knowledge that's required to operate in this new environment. The sources argue pretty compellingly for a necessary shift toward comprehensive AI literacy, stating unequivocally that it can no longer be treated as some optional, specialized topic reserved only for computer science majors.
It has to be treated as a fundamental utility skill. It's on par with understanding how to use the internet or manage digital files.
So students in all fields, history, marketing, nursing, engineering, they all need a foundational understanding of what AI can accomplish.
Its power of prediction, analysis, generation. Yes.
But just as important is establishing its boundaries. What are the limitations that everyone needs to grasp?
Understanding what AI cannot accomplish is vital for responsible deployment. AI currently lacks genuine empathy, true consciousness, real-world context, and the capacity for moral judgment,
So an AI can process millions of patient records to suggest a diagnosis.
which is a remarkable technical feat.
Right, but it cannot provide the necessary human comfort or nuanced ethical decision-making that's required in a bedside situation.
And we have to delve deeper into the ethical implications, especially around data privacy and algorithmic bias, because these issues touch every single discipline.
This knowledge seems paramount for future leaders.
Every student have to grasp the ethical implications. They have to understand the mechanism of algorithmic bias. For instance, if an AI used for grading is trained primarily on academic data from high-income school districts,
Then it might inadvertently develop patterns that flag the writing style common in lower-income schools as at risk or substandard.
exactly. The system itself, through its biased training data, can perpetuate existing inequalities.
And that demonstrates why AI literacy is essential, even for non-technical users. If you don't understand the mechanism of bias, you can't audit or challenge the system's output effectively.
You can't, which requires a profound shift in how higher education operates.
Uh,
Universities have to integrate AI knowledge across the board, moving it beyond the traditional siloed computer science departments.
the focus has to shift away from purely theoretical computer science toward integrated real-world application.
The emphasis is on problem-solving using AI tools. It's about blending technical skill with essential business knowledge, system thinking, and disciplinary knowledge.
So it's about asking questions like, how does a literature major use natural language processing models to analyze themes across 5 centuries of poetry?
Or how does a civil engineer use predictive ML models to optimize infrastructure maintenance budgets? The curriculum has to focus on integrated, interdisciplinary learning centered on tangible, real-world use cases.
So understanding AI is becoming as fundamental and important as understanding the principles of statistics or basic economics.
It really is.
So it's a basic requirement for navigating modern professional life.
It is the new foundational utility. You don't need to be able to program the core ML model from scratch, but you absolutely need to know how the system works, how to interface with it effectively, and how to use the output safely and ethically in your specific domain.
Okay, now let's pivot to this specific technical tool that underpins so much of this AI transformation, the programming language Python. The source material argues its importance is critical. Why Python? Why is it the language of this new era?
Python's dominance is it's overwhelming. And it's driven by this unique combination of accessibility and massive professional utility. We can detail the 3 primary reasons it became the most important language for AI and data analysis.
Okay, reason 1, its celebrated syntax.
It has a simple and highly readable syntax. Unlike dense, older programming languages that require immense boilerplate code, Python reads remarkably close to plain English.
Which dramatically lowers the barrier to entry for students who aren't computer science majors but still desperately need to analyze data.
Researchers processing sensor data, sociologists analyzing survey results, marketers tracking campaign performance. It's for everyone.
Okay, reason 2, which seems like the functional heart of its success, the ecosystem of libraries.
This is the most powerful factor. Python has a massive, mature, and rich ecosystem of specialized libraries that are optimized precisely for AI and data analysis.
Things like NumPy and Pandas for data manipulation.
Scikit-learn for classical machine learning, and TensorFlow or PyTorch for deep learning. These open-source libraries handle all the complex, heavy-lifting mathematics and resource management.
Which means the developer or the researcher can focus their intellectual energy entirely on the problem they're trying to solve.
Instead of spending months writing complex statistical code from scratch.
Right. And finally, community support and versatility.
The support is robust and ubiquitous. Python isn't just used for AI. It's dominant in data analysis, automation scripting, back-end web development. It's everywhere.
So if a student runs into a problem, a solution is almost always readily available.
The sheer volume of documentation, tutorials, community forums, it just significantly accelerates learning and professional development.
But the importance of Python goes beyond just coding proficiency. The sources really emphasize its cognitive benefits as a problem-solving tool that fundamentally trains the mind.
Absolutely. Learning Python instills cognitive benefits that are immensely transferable to any field, technical or not. It enforces logical, structured processes.
To write a functional script, you have to break down a complex, messy, real-world problem into clear sequential steps.
Steps the computer can execute. This disciplined, modular approach Aids in general system design principles, how to structure inputs, processes, and expected outputs.
A critical skill, whether you're designing a business strategy, an organizational flowchart, or a data pipeline.
And the act of debugging then becomes this powerful exercise in logical deduction.
Totally.
When a program fails, you learn to systematically trace the logical flow, identify the point of failure, and formulate an elegant solution. This rigorous process facilitates data-driven decision-making and efficient automation in any domain.
So the mandate is undeniable. Python literacy may soon become as non-negotiable as basic computer proficiency.
If you can't functionally work with data and structured logic, you will struggle to operate effectively in any professional environment that's powered by AI.
So if AI is the engine that's driving this educational revolution, we need to project where that engine is taking us. What do the sources predict the future landscape of learning will look like?
How will it differ structurally from the system we know today?
Right.
The sources project a dramatic and necessary structural shift. We're moving away from the monolithic, time-bound idea that learning just stops after a single 4-year degree.
The velocity of change requires the education system itself to become dynamic.
Exactly.
Okay, let's look at the 4 major future trends identified. Start with the most pervasive one, lifelong learning.
First, lifelong learning is moving from a nice-to-have ideal to an operational requirement.
It's a necessity now.
The pace of technological disruption means that skills you acquire today, even those highly specialized Python skills we just talked about, will likely be partially obsolete in 5 to 10 years.
So continuous adaptation is not optional, it is expected.
And future education has to be designed as a continuous loop of frequent upskilling and reskilling throughout a career. That means you need modular, on-demand content that's accessible via these AI-guided platforms.
Okay, secondly, the market focus shifts away from generalized credentials.
That's skills-based education. The emphasis is moving rapidly toward demonstrable, practical abilities over generalized credentials. Employers are increasingly seeking validation of what you can do today.
And the sources highlight that this shift is being facilitated by technology.
Right. Think of AI-powered assessment platforms that test practical skills, or systems like blockchain verification for securely managing digital skills-based credentials and portfolios.
So the degree becomes the minimum entry point.
But the portfolio of demonstrable skills becomes the currency of advancement.
Third, how will we assess knowledge if we are moving away from the standardized final exam?
We are shifting fundamentally toward project-driven assessment. Moving away from static memorization-based testing, students will be judged on their ability to solve complex, novel, and open-ended problems using all available tools.
Including their AI assistants.
Including them. This type of assessment simulates the real-world environment where problems are messy and resources are available. It focuses on synthesis, judgment, and application, not just mere recall.
And finally, the role of AI in shaping the curriculum itself will fundamentally change.
That brings us to AI-assisted learning paths. Curricula will become entirely customized and dynamically guided by technology.
So if an AI identifies a new high-demand skill emerging in the market, say prompt engineering for a specific industry,
the student's learning path can adapt almost instantly to incorporate that necessary module. This makes the entire education system vastly more responsive to market, professional, and societal needs.
So the new measure of success moves well beyond just receiving a diploma.
Success will be defined by practical skills, intellectual flexibility, and the meta capacity for continuous learning, knowing how to acquire new complex knowledge quickly.
The individual who can learn Python today, use it to solve a data problem, and then a year later, pivot to master a new AI framework.
That's the person who will thrive. The value lies in adaptability, not in static knowledge accumulation.
This all sort of coalesces into the ideal environment, the hybrid classroom where the human element and the machine element find their perfect synergy.
That synergy is the goal. The ideal future classroom will be a place where the human component, the teacher, the students, focuses entirely on irreplaceable human attributes.
Creativity, critical interaction, ethical dialogue.
Complex, nuanced problem solving. Meanwhile, AI is leveraged fully for processing massive amounts of data, optimizing delivery, providing personalization, and handling all the necessary informational and administrative support.
It's a true, powerful collaboration.
And the ultimate goal of all this transformation remains profoundly human. It's about intellectual flexibility powered by technology. The sources conclude that those who master how to learn, how to adapt, and how to utilize technology wisely are the individuals who will not only succeed, but will lead the development of this new landscape.
This has been an extensive and I think a necessary deep dive into the AI transformation of education. The central thing that ties all our sources together is that AI is here to enhance human potential and transform the system.
Not to replace the fundamental purpose of learning.
Right. The ultimate goal remains creating better learners, better thinkers, and more adept problem solvers.
And to succeed in this fast-moving environment, you, the learner, have to concentrate on three fundamental focus areas.
Okay.
First, achieving true AI literacy by understanding the underlying technology, the mechanics of data, algorithms, and computing power.
Second, using AI ethically and responsibly.
Ensuring you master prompt engineering and maintain a robust skepticism toward its output. And third, focusing on building systems, mastering practical foundational skills like Python, not merely consuming the technology passively.
It requires moving from being a passive recipient of information to an active architect of your own knowledge and your intellectual toolkit.
And that leads us to our final provocative thought for you to consider as you wrap up this deep dive.
Okay.
Since AI systems learn patterns exclusively from the data they are fed, and the sources stress that the quality of the AI depends entirely on the quality and integrity of that data, what critical and ongoing role must human educators, data scientists, and students play in vetting, curating, and shaping the immense data sets that define the future of learning? If the data is flawed, the education is flawed. The future of learning is not something we passively wait for. It is something we must actively learn to build and rigorously audit.